Welcome to the Unit 2 final review. Yeah. Stitch is still here, if you were worried about him. He's just chilling in the chair. All right. So here we go. It says factor the following. So this is actually number 7, but it's the first one on the Unit 2 part. So factor the following. So when you're trying to factor, you want to think of 2 factors of C. Oh, this is in standard form. Okay, standard form of a quadratic. So you have ax squared plus bx plus c. So factors of c that add up to b. So what you can always do is make a table. Factors of c. So I don't know, let's do 36, 12, and 3. 12 times 3 is 36. But then what do they add up to? 12 plus 3 is 15. So that's not right. I need it to be 13. So no. All right, what about 36? Factors of 36. Let's do 6 and 6. 6 times 6 is 36. But then let's see, add them up. That's 6 plus 6 is 12. I need it to be 13. So no. Let's see what else. So 9 and 4. 9 times 4 is 36. 9 plus 4 is 13. Aha! So 9 and 4 are my factors. So let me erase this. So my factors are x plus 4 times x plus 9. Okay. If you could write them in either order. If you want to write x plus 9 times x plus 4, it doesn't matter. So you just went from the standard form of a quadratic to factored form. We just went from standard form to factored form of a quadratic. That's just a little extra thing, you know. All right. Let's try the next one. Okay, this is number 8. So once again, you're factoring. So please try this by yourself first and then come to me if you need help. So if you haven't tried it by yourself yet, go ahead and pause me and try it by yourself. Did you pause me? All right. So here we go. Factors of C, which is -10, that add up to -9. Okay. Let's think about this for a second before I start going. My numbers have to multiply to equal a negative number. Factors of -10. A positive times a positive is a positive. A negative times a negative is also a positive. So I need one of my factors is going to be negative, and the other one's going to be positive. That's the only way I can get a negative number here, is if one is positive and one is negative. Do that. Okay, so keep that in mind. So let's see, -10. So let's do -5 and +2. Right? -5 times +2 is -10, but then add them up. -5 plus 2 is -3. It needs to be -9. So no. All right, what if I switch it? What if I go -2 and +5? That's still -10 if I multiply them, but if I add them up, that is +3. Okay, no. We're getting further away. Other factors of 10. You have -1 and +10. That equals -10. But if I add them up, I get 10 minus 1, that's +9. Ooh, that's close, but no. I need it to be negative. So let's switch it, -10 and +1. Multiply them together, you get -10. If you add them together, you get -9, which is what you were looking for. So your factors are -10 and +1. So once again, let's do R of x. You just went from standard form to factored form of a quadratic. Okay, number 9. So for 9 and 10, you have to find the vertex, the axis of symmetry, and the y-intercepts. So this is given to you in vertex form. Okay, if you don't have these written down, oh my goodness, you do somewhere. But if you can't find them, here are the 3 different forms of a quadratic. So I have standard form, and that is ax squared plus bx plus c. That's standard form. Then I have vertex form, which is what this one is. F of x equals a x minus h squared plus k. And the last one, oh goodness, is factored form, which is what we just saw in the first two. So it is f of x equals a, which in ours there wasn't an a. A is the stretch or shrink. And then I don't know why they call p and q the factors, but they do. Okay, those are your 3 different forms, where p and q are your factors. Okay. Okay, get those written down. Well, pause me if you need to and write those down, because I'm going to erase 2 of them. Okay. So, if we're given vertex form, which we are, you can pull the vertex straight out of it. Just so, your vertex is h, k. H is the x value of your vertex, k is the y value. Okay, so for this one, my vertex is +5. It's the opposite of what you see in here. So +5 and +7. That is my vertex. Okay, this does not affect my vertex. The 3 does not affect my vertex. My axis of symmetry, that goes straight through my vertex. Remember, if I were to graph a parabola, my axis of symmetry goes straight through my vertex. Every time. Always. Always and forever. So it is just x equals, so this is 5 for this problem. Oh, I didn't graph that accurately, so let's not say that. So it's just equal to whatever your x value is of your vertex. So this one is x equals 5. Okay? So if you know the vertex, you know the axis of symmetry. The last thing is finding the y-intercept. Okay. Whenever you're asked to find the y-intercept, substitute 0 in for x. You can always do that because your y-intercept is going to be x equals 0 and y equals something. X was always 0. X is always 0 for the y-intercept. If that's my y-intercept, x is 0, y is, I don't know, let's say that's 5. So that would be 0, 5. If that's my y-intercept, -4. There would be 0, -4. X is along your y-axis, x is equal to 0. So you can always substitute 0 in for x. So let's do that. I'm tired of green. Let's see if purple shows up. So I'm going to substitute 0 in for x. So f of 0, yeah, that's fine. Oh, I already forgot what I was doing. 0 minus 5 squared plus 7. Okay, all I did was substitute 0 in for x. Where am I out of time? Okay. This is equal to 3. 0 minus 5 is negative 5 squared plus 7. My purple's starting to die. Where's my red? There it is. Ugh. There we go. So 3, negative 5 squared. Negative 5 times negative 5 is positive 25, and then plus 7. Are we good? Yeah. 3 times 25, 75, plus 7 equals 82. So your y-intercept is 0, 82. So substitute 0 in for x and solve. All right. Okay, number 10. Same thing, you have to find the vertex, axis of symmetry, and the y-intercepts. I'm always so conflicted because there are a few different ways you could do it to find the vertex. The easiest, well, I shouldn't say that. I think the easiest way is if I have a parabola, there's my vertex. Your vertex is always halfway between your x-intercepts. Okay, your vertex is halfway in between your x-intercepts. So, you're given factored form, so your x-intercepts are the opposite. So your x-intercepts are, your x-intercepts are what make this equation equal to 0. Your x-intercepts are what make this equation equal to 0. So that would be x equals positive 6 and negative 2. Because if this is positive 6, then this whole thing is 0. And 0 times anything is just 0. So same thing over here. If this is negative 2 plus 2, that's 0. 0 times anything is 0. So your x-intercepts are what make this whole equation equal to 0. All right, now that you know your x-intercepts, your vertex is halfway in between. So you can add them together. So 6 plus negative 2, which is 4, and then divide by 2. And that equals 2. If you don't want to remember that, you could always use a number line. Like, Miss Bailey, I don't have a number line. Well, no, neither do I. But, well, no, neither do I. You could write them out. So let's see, negative 2, negative 1, 0, 1, 2, 3, 4, 5, 6. Okay. And then figure out which one's in the middle. So just cross off at each end, cross off, cross off, cross off. And you'll get the same answer that we just got. But adding them together and dividing by 2 is faster, I think. So now we know the x value of our vertex. It's 2. But we need to figure out we need to figure out the y value. So when x is 2, what is y? When x is 2, what is y? Let me erase this. So you're going to substitute 2 into your original equation. Okay? 2 minus 6 is negative 4. Is there a glare right there? Kind of. Yeah. And then times 2 plus 2 is positive 4. So negative 4 times positive 4 is negative 16. So that is your vertex, is 2, negative 16. So now that you know your vertex, what's your axis of symmetry? It goes straight through your vertex. So it's x equals 2. All right, and then your y-intercept, to find your y-intercept, substitute 0 in for x. Zero minus 6 is negative 6 times 0 plus 2, 2. So you get negative 12. So your y-intercept is 0, negative 12. Make sure I agree with myself, and I do. So number 11 says, given factored form, this is factored form of a quadratic, convert to standard form. So how you do that is by FOILing, which is our two-part distribution. All right? So start with your x. X times x, here. X squared, x times 8 is 8x, and then you're done with your x. Move on to your 4. 4 times x is 4x, and then 4 times 8, 4 times 8 is 32. Don't stop there. Combine your like terms. X squared, rewrite. But then I have two things that have an x, so I can add those together. That's 8. 8x plus 4x is 12x plus 32. So factored form, standard form, and you're done. Number 12, you are given standard form. You have to convert to vertex form. So you're given standard form, convert to vertex. Convert to vertex. How you do that is by completing the square. Now, how we learned it in Unit 2, we stayed on this side of the equation the whole time. So we're going to do it that way. So h of x equals, the first thing you're going to do is put a and b in parentheses, your first two in parentheses. Okay, you complete the square within those parentheses. So x squared plus 18x plus some number. And then on the outside, you have minus 12. And since we're doing it on the same side of the equation, we're doing it all on one side, whatever you add here, make sure you subtract it out. So these two numbers will be the same thing. All right. So to complete the square, that's the whole b over 2 squared. To find that. So 18 divided by 2. 18 divided by 2 is 9. And then square. 9 squared is 81. 81. Now, we just made this a perfect square. So you're going to write it in factored form, but you're just going to take half of your middle term. So it's x plus 9 squared. And if you want to check, 9 and 9 are the factors here. 9 times 9 is 81. 9 plus 9 is 18. And then on the outside, you have negative 12 minus 81, which is negative 93. Okay? This is now in vertex form of a parabola. Okay, so A is the stretch or shrink, so there's nothing there. So that means there's no stretch or shrink. And then our vertex would be negative 9, the opposite of what you see, and negative 93. That would be your vertex. You don't have to write that, but just good practice to pull it out. All right, that is number, whatever that was, 12. Okay, number 13. You are describing, oh, this is A, 13A, my bad. Describing the transformations of the parabola. So 13A, so it's in vertex form, which once again is A x minus h squared plus k. That is vertex form of a parabola. So A is your stretch or shrink. So also, the first thing we have is a negative. So I'm just going to look left to right. So we have a negative. This means it is reflected over x-axis, Okay, so the negative means you're reflected over the x-axis. Okay, the 2, so there's a stretch of 2. Whatever is inside with the x moves it either left or right. So x minus 5, we move 5 right. 5 to the right. If it was positive, we would move 5 to the left. And then k is up or down. So we go up 4. Up 4. If it was negative, we would go down 4. Okay? Okie dokie. And I said this in class. If you want to graph this, you can't use Desmos on the test. But if you want to graph this for practice and see what it does, you can use Desmos. I'll write it down again. You cannot use it on the test, but it's good practice. If you're having trouble seeing transformations and you don't want to graph them all yourself, graph them on Desmos and see how this moves your parabola around. Your regular parent function, your regular parabola is, okay, so that's your normal one. So maybe graph the normal one and then see what do all these things do to it? What do all these changes do to it? Okay. All right, this is 13b, negative 2x squared minus 3. So you're describing the transformations. So we'll go from left to right again. I have a negative. What does that mean? We're reflected over x axis. Okay, negative 2. What's the 2 mean? Oh, sorry. That means we have a stretch of 2. So this is going to be skinnier than the normal parabola. This is a stretch of 2. It makes it skinnier. Then there's nothing inside the parentheses with the x. It's just x squared. So we are not moving left or right at all. So we're not moving left or right at all. Remember, you could rewrite this. Get rid of this. Negative 2. Oh, not minus 13. Minus 3. You could rewrite it like that. But why write minus 0 when it doesn't do anything? X minus 0 is just x. So it's just x squared. So we're not moving left or right at all. And then we move down 3. Okay. So that's how this parabola is transformed. Okay, number 15. Nope, number 14. So we're going to write the equation of a parabola with the following transformations. So let's just call it f of x. So I have a stretch of 1/2. So that means a equals 1/2. And then inside, do I go left or right at all? Do I go left or right at all? I go right 4. So minus 4 squared. And then I shift down 3. So k is negative 3. So that is number 14. And the last one of unit 2, it says complete the square. So what number would go here to complete the square? So we did this earlier. Oh, when we were going from standard form to vertex form, we did this. We completed the square. So that's where you take half of b, so half of 24, half of 24 is 12, and then you square it. So that's 144. Remember, this formula is b over 2, 24 divided by 2 squared. Okay. Ta-da! And that is it for Unit 2. Whew! Good job.